Welcome to Kishore's Neet Padasala. In this video lecture, we will see about the first topic of laws of motion chapter, that is Newton's laws. There are three Newton's law. Let us see the first law of Newton. Newton's first law states that every body continues to be in the rest or motion unless acted by some other external force. That is, suppose if a car is moving, it will be in the motion till another force act on it to stop it. Or suppose if the car is at rest, it will be at rest till some other force acts on that car to move it. This is only stated by the Newton's first law. And Newton's first law, it gives the concept of law of inertia. What is inertia? Inertia means it is the inability of the object to change its state. There are three types of inertia: inertia of rest, inertia of motion, inertia of direction. If it is the inability of an object to change its state of rest, then it is known as the inertia of motion. And if it is the inability of the body to change its state of motion, then it is the inertia of motion. Then if the body's inability to change its state of direction, then it is the inertia of direction. Now let us introduce a new term in this chapter, which is the momentum. Momentum we are indicating by P. Momentum is equal to mass into velocity. This is the formula of momentum. Momentum is equal to mass into velocity. Suppose if m is constant, then momentum is directly proportional to v, which we are indicating by a straight line. Suppose if velocity is constant, then momentum is directly proportional to mass. So the graph for momentum versus mass is a straight line if velocity is constant. Newton's second law. Newton's second law gives us a very useful relation that it states that the force acting on the body is the rate of change of momentum. So which is m into v by dt. M is, I am taking it outside, so m into dv by dt. dv by dt is nothing but acceleration, so it is ma. This is a very useful relation and most common relation of Newton's second law. Now let us see what is the unit of force. SI unit of force, that is standard system unit is the Newton, which is indicated by capital N. CGS system, that is centimeter gram second. This system states that the unit of force is dyne, dyne, and 1 Newton is equal to 10 power 5 dyne. This you must remember for doing out numericals. Suppose if they are giving that velocity is constant, then they are asking what is the force acting on it. We know that force is equal to dp by dt. So that is equal to m into dv by dt. Here they have given that velocity is constant. If velocity is constant, then rate of change of velocity will be 0. Because the velocity is constant, velocity is not at all changing, then rate of change of velocity is 0. So m into 0, that is equal to force is equal to 0. Okay, if velocity is constant, then force acting on a body is 0. Then another one we can write that momentum is force is equal to m into dv by dt. So dv is the change in velocity, so m into v minus u by dt we can say. This is also a relation which we use for doing numericals. Now let us see a numerical based on the concept we have learned till now. See that our 2 kg block, the 20 Newton force, 10 Newton force, 12 Newton force are acting. Find the acceleration. Net force is equal to ma. This is the relation we learned in the Newton's second law. So net force is, see here there are total of 22 Newton force, here 20 Newton force. So the object will move in the direction where the more force is there. So it will move rightwards. So which is 22 minus 20 is equal to 2 into A. Acceleration comes out to be 1 ms per minus 2. Now let us see the next question. A car of mass 10,000 kg moves with constant velocity of 40 km per hour. Find the force acting on it. Force is nothing but m into dv by dt. If velocity is constant, if velocity is constant, then dv by dt is 0. So the force acting on the car is 0 Newton. Let us see this numerical. A constant force of 5 Newton produce acceleration of 1 ms per minus 2 on m1. So force is equal to ma, we know. So 5 Newton produces an acceleration of 1 ms per minus 2 on m1. So m1 is equal to 5 kg. We found out. Next, let us see the second thing. And the same force 5 Newton produces 2 ms per minus 2 on m2. So 5 Newton is equal to m2 into 2. So m2 is equal to 5 by 2 kg. We found out the m2 value also. If both m1 and m2 are tied together, then what is the acceleration of the system, they are asking. So again, this 5 Newton is acting on this both the bodies, but both bodies are now tied together. So the net mass is m1 plus m2 into acceleration. So 5 is equal to 5 plus 5 by 2 into acceleration. So 5 is equal to 5 into 3 by 2 into A. So the acceleration value comes out to be 2 by 3 ms per minus 2. Okay, this is a next question we are going to see. See, a truck is moving with initial velocity of 90 km per hour. There is a block on it whose mass is 500 kg. Then we are putting the brake. Then after 10 seconds, the vehicle is moving at 54 km per hour. Then they are asking what is the force acting on it so that the speed decreases from 90 to 54 km per hour, they are asking. Okay, so we know the relation from kinematic equation. V is equal to u plus at. Final speed is 54 km per hour, initial speed is 90 km per hour, plus a into time is 10 seconds. So kilometer per hour will be converted to ms per minus 1 by multiplying it by 5 by 18, that is equal to 90 into 5 by 18 plus 10a. So the value of acceleration, it comes out to be minus 1 ms per minus 2. So we know the force formula, which is ma. So on 500 kg block, there is an acceleration of minus 1 ms per minus 2. So the value of force is minus 500 Newton. So here the negative sign indicates that force is opposite to direction of velocity. So you see that if we are putting the brake, which is nothing but we are trying to stop the vehicle, so the force applied is opposite to the direction of velocity. Just you can think in a simple manner. If you are stopping the vehicle, we are doing nothing but we are creating one force which is created by the brake, which is opposite to the direction of velocity. Now this is the last numerical we are going to see. On an object of mass 1 kg moving along x-axis with constant speed 8 ms per minus 1. So see that initial velocity is moving along 8. Initial velocity it is 8 ms per minus 1 along x-axis. So it is, I am putting 8 I cap. Next, a constant force of 2 Newton is applied in a positive y direction. The force is 2 Newton along positive y-axis, so I am indicating by 2j cap. Find the speed after 4 seconds. So I told her